G 2.5 Area of Trapezia. The area of a shape is the total space taken up by the two-dimensional shape. In lesson G 2.2, we looked at how to find the area of rectangles. In lesson G 2.3, we looked at how to find the area of parallelograms, and in lesson G 2.4, we looked at how to find the area of triangles. In today's lesson then, we will look at how to find the area of trapezia. Remember that the units we use for area are millimetres squared, centimetres squared, metres squared, and so on. Let's have a look at our questions. Question 1. Work out the area of each shape below. Part A. This diagram is drawn on centimetre squared paper. So this trapezium is drawn to scale on centimetre squared paper. Each small square is 1 centimetre long and 1 centimetre wide, therefore has an area of 1 centimetre squared. In order to find the area of the trapezium then, we simply count up how many 1 centimetre squares make up the trapezium. As I count, I will tick off the squares. 1 centimetre squared, 2 centimetres squared, 3, 4, 5, 6 whole 1 centimetre squares, and then this part and this part go together to make another 1 centimetre squared. So the area of this trapezium is 7 centimetres squared. Let's have a look at part B. We need to work out the area of this trapezium. This one is not drawn on centimetre squared paper. In fact, it is not drawn to scale at all. We are told that the measurements of the trapezium are 2 centimetres long for one of the parallel sides, 8 centimetres long for the other parallel side, and a perpendicular height, so a height that is perpendicular or at right angles to the base, of 9 centimetres. When a shape is not drawn to scale, you must use the measurements provided. So how do we work out the area of a trapezium like this? Let's have a look back at part A. If we cut the triangle off the side of the trapezium like this, we get a rectangle with an area of 3 centimetres multiplied by 2 centimetres so 6 centimetres squared. If we extend the trapezium like this, to create a rectangle by drawing lines perpendicular to the base and to the perpendicular height, we get a rectangle with area of 4 centimetres multiplied by 2 centimetres, so an area of 8 centimetres squared. The first rectangle we drew, where we used the shorter parallel side as the length of our rectangle, gave us an area that was smaller than our trapezium. The second rectangle we drew, where we used the longer parallel side as the length of our rectangle, gave us an area that was bigger than the area of the trapezium. The actual area of the trapezium is exactly halfway between these two areas, halfway between 6 centimeters squared and 8 centimeters squared. So, we therefore get the area of the trapezium by first of all finding the average or the mean of the two parallel sides. So in this case, the mean of 3 centimeters and 4 centimeters. We do this by adding up the numbers and then halving the answer. 3 add 4 is 7. 7 divided by 2 is 3.5. So the mean of the two parallel sides is 3.5 centimeters. We then multiply this answer by the perpendicular height of our trapezium, in this case 2 centimeters. 3.5 centimeters multiplied by 2 centimeters is 7 centimeters squared, the area of our trapezium. Let's go back to part B then and use this method. The mean of the parallel sides is 2 plus 8 divided by 2. And then we multiply this by the perpendicular height, 9. So 2 centimeters plus 8 centimeters divided by 2 is 5 centimeters. That is the mean of our parallel sides. And then multiplied by our perpendicular height, 5 centimeters multiplied by 9 centimeters gives us an area of this trapezium of 45 centimeters squared. We can write this down as a formula. If we have got a trapezium where one of the parallel sides is A and the other parallel side is B, and the perpendicular height, so the height that is at right angles to the base, is H, then the area of this trapezium is found by working out the mean of the parallel sides. So working out the mean of the parallel sides A and B by doing A add B divided by 2, and then multiplying this answer by the perpendicular height H. So it's your turn to have a go at some questions like these then. In the first set of questions, the trapezia are drawn on centimetre squared paper, so you can simply count the squares. In the second set of questions, the trapezia are not drawn to scale. You will need to use the measurements provided. You will need to use the formula area is equal to A plus B over 2 multiplied by H, where A and B are the parallel sides and H is the perpendicular height. Pause the video to copy the notes, to check your understanding and to try the questions from I'm giving it a try. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Part C. We need to work out the area of this trapezium. Now part C offers us a few challenges. Firstly, the trapezium is not drawn in a familiar way. It has been rotated. It often helps to redraw it the usual way up, making sure we label the measurements correctly. The next challenge is that the measurements are not all given in the same units. We've got a mixture of millimetres and centimetres. We need to convert some of the measurements before we use them in our calculations. Either centimetres or millimetres, whichever you prefer. I'm going to use centimetres. So 14 millimetres, I know that in 1 centimetre there are 10 millimetres, so 14 millimetres is the same as 1.4 centimetres. And then the other measurement that's in millimetres is the 20 millimetres. So this is equivalent to 2 centimetres. Finally, you may have noticed that we have been given too many measurements. Remember the formula for the area of a trapezium is A plus B divided by 2 multiplied by H, where A and B are the two parallel sides and H is the perpendicular height. So the measurements we need to use are the two parallel sides, 1.4 centimetres and 3.8 centimetres, and also the perpendicular height, 1.6 centimetres. We do not use the diagonal height. Now we can finally use our formula to calculate the area of this trapezium. So the area is A plus B divided by 2, so 1.4 centimetres plus 3.8 centimetres divided by 2. This finds the mean of the parallel sides, and then multiply this by the perpendicular height, 1.6 centimetres, giving us an area of 4.16, and because we have been using centimetres throughout, the units for our area are centimetres squared. If you chose to use millimetres throughout this question, then you would have got an answer of 416 millimetres squared for the area. Both of these answers are equivalent to each other. So it's your turn to have a go at some questions like these. Watch out for any trapezia that are drawn in an unfamiliar orientation. By all means redraw them, just be careful that you label the correct measurements in the right places. Watch out as well for any units that don't match. Make sure all your units match before you do any calculations. And finally, watch out for any measurements given that are not needed. We do not use the diagonal sides when working out the area of a trapezia. Pause the video to copy the notes, to check your understanding and to try the questions from I'm Building My Confidence. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Question 2. The area of the trapezium below is 42 centimetres squared. Find x. So in this question we are given the area of the trapezium and we need to work backwards to find the value for x. So first of all, I'm going to write down the formula for the area of the trapezium. We then fill in what we know. So we know that the area is 42 centimetres squared. We know that A and B our parallel sides are 5 centimeters and 9 centimeters, and our perpendicular height is x. Now we have got an equation in terms of x, we simply need to solve for x. So I'm going to start by working out what is inside the bracket. So we've got 42 is equal to, well, 5 plus 9 is 14, 14 divided by 2 is 7. So we can simplify this as 42 is equal to 7 multiplied by x. Now we need to get the x on its own, so we need to do the opposite of multiplying by 7. We divide both sides by 7. 42 divided by 7 is x, so x is equal to 6. And the units, because we have used centimetres and centimetres squared throughout, the units for x is centimetres. So the final thing we need to do is just check that our answer is correct. So using the measurements that we have got and we've calculated, we need to work out the area of this trapezium and make sure it matches the area we are given in the question. So we've got a plus b over 2, that's 5 plus 9 over 2, multiplied by the perpendicular height, which we've just calculated to be 6. So 5 plus 9 over 2 is 7, 7 multiplied by 6 is 42. Let's check our units. We had 5 centimetres, 9 centimetres and 6 centimetres, therefore our area should be in centimetres squared, and this is the area that was given to us in the question. So I'm happy that my answer for x being 6 centimetres is correct. So it's your turn to have a go at some questions like these, where you are given the area of the trapezium and you have got to work backwards to find the value for x. Pause the video to copy the notes, to check your understanding and to try the questions from I'm ready for anything. Remember to mark your work and reflect on your confidence.